Another instrumental method of analysis is atomic absorption spectroscopy. So this is a basic instrument of atomic absorption spectroscopy. So the spectroscopy is used to measure both metals and non-metals, almost most metals, and some non-metals can be identified and used by Allen walls. So we can estimate the amount of the metals, non-metals, which is present in a sample at the gram per ml level or ppm. So here what happens, the molecules, the sample has been heated and it is being taken to a atomic state through a flame where the light has been passed. So some amount of things will be observed. So the gaseous state, it observes some ultraviolet or visible region and makes to an excited state, and here the absorption has been directly related to the concentration. Okay, so samples should be highly diluted. The sample should be decomposed at a different temperature, which is a wet acidic decomposition or a dry acid decomposition, microwave decomposition. Different types of decomposition should be applied. So this is sample preparation. And how it works: the atoms of a solid state are converted into a gaseous state by an atomizer. So atomizer which makes the molecules into an atoms at high temperature. The radiation of specific wavelength from a halo cathode lamp should be passes the light there. There will be a monochromator which focuses certain wavelength over the material. So some type of absorption may takes place. So a detector will detect the amount of absorption of light, then it is being directly related to the concentration. So hollow cathode lamp passes the light, the flame is here, atomizer, so which gives an atoms. So light when is passed, some part of light is observed here, certain things are transmitted, so it is observed by the monochromator. So photomultiplier will take this and take to the detectors. Yes. So hollow cathode lamp. The hollow cathode lamp, so there will be different types of lamps. Cathode lamp is hollow cylindrical thing. It is made up of tungsten. Both anode and cathode, high voltage is applied between this, and the inert gases get ionized. So because of this, we get some light for required wavelength. Hollow cathode lamp. So nebulizer makes a mist or aerosol of the sample. So this will be forced into the atomizer with some high pressure. So atomizer which vaporizes the sample molecules can be converted into atoms. There's a flame atomizer or electrothermal atomizer. So diagram has been given. Flame atomizers. This is an electrothermal atomizer. Yes. So it uses a graphite rods. So in chemical interference, the presence of thermal stable compounds that is not totally composed of energy of flame. High flame temperature provides energy that break down an interference. So the addition of a releasing agent will reacts with the interference. So the interferences should be avoided. So the matrix interference, background absorption, this will go through with this. These are very important for your exam point of view. So what about the application? So matrix interference means due to viscosity, burning characters of the surface tension of solvent. We need some calibration for different solvents, so that addition of diluent should be added. It should be diluted, and as I said beginning, the sample should be highly diluted so that it reduces the viscosity. So background absorption, scattering should be avoided. So it depends upon the final calibration. So application, so the level of metal should be detected, like aluminum in blood, copper in brain tissues. These things can be detected. Impurities in alloys can be identified. Elements in agricultural products can be identified. Lead present in petrol can be determined. Magnesium, calcium in cement, water, etc. can be determined. The great disadvantage and advantage and disadvantages. The advantage is highly sensitive equipment, easy to use, inexpensive. Just by injecting a small amount of sample in a diluted form, we can get what type of elements present in it. That's very easy. The major disadvantage is using of a cathode lamp for different elements. Some elements need a different range of light source. Some needs different range. So depending upon the light, depending upon our need, we need to change the cathode lamp. Can detect only metals, certain metals. Not all the metals can be detected, and also detect only certain non-metals. It cannot. With this, we cannot determine. We cannot detect all the elements which have been found in the periodic table. Certain things have some restrictions. So only one metal, only one element can be detected at a time. But some recently there are advanced equipments are there, so several metals can be detected at one time. So thank you. We'll see you next class.